In this lesson, we're going to learn about direct variation, and we're going to start with 3 different problems that represent direct variations. What I want you to do for each of these problems is first copy them into your journal, answer the questions about how much it costs or how much you would make or how far you could go. Answer those questions, and then write a function for each one of these. So please stop the video while you do that. Copy these into your journal, as I said, solve the problems, and then restart the video when you're done to check your answers. All right, let's take a look at the first problem. So 5 pens will cost $1.50 and 11 pens cost $3.30. So you can probably figure out that if you divide $1.50 by 5 or $3.30 by 11, you'll get the cost for 1 pen. So 1 pen costs 30 cents, and then you multiply 30 cents by 10 to get the cost for 10 pens, and so on. Now the function for this problem is C equals 0.3 P, or C equals 30 cents times the number of pens. Now that 30 cents is the price for each pen. That's how it appears in the equation. And we call that number in this function or this equation the constant of variation. It's also, we may have learned slope, so it's also the slope, and it's also a rate. It's the price for each pen, the price per pen. In this situation, because it's a direct variation, we say that the cost varies directly with the number of pens. When we say that, we mean that this is a direct variation. Let's quickly take a look at the other 2 problems. Here are the answers for the babysitting. If you make $8 an hour, there are the numbers that you would make for each of 3, 8, 15, or 24 hours. The function would be y equals 8h, or y, you can use any variables, but y equals 8 times the number of hours. 8 is the cost per hour that you get, and it is also the constant of variation. And we say that the amount of money that you make varies directly with the number of hours you work. For the third problem, if you bicycle 18 miles in 2 hours, well, you can probably figure out that you would go 9 miles in 1 hour. And then you can see the answers for the others. The function for this would be d, the distance, equals 9 times t, the number of hours, the time that you bicycle. And 9 is the speed in miles per hour, and it's also called the constant of variation. And we say that the distance varies directly with the hours you bicycle. Now you might ask, if I look at a table, how can I tell if this table represents a direct variation? Well, one of the first things to look at is the value of y when x is equal to 0. In a direct variation, y will be 0 always when x is 0. So if you see this x is 0, y is 0, that's a clue that this might be a direct variation. If there were some other number other than 0 in y when x is 0, then you know immediately that it's not a direct variation. The next thing to do is for each pair, 1, 4, 2, 8, and so on, divide y by x, and then if all of the results are the same, it's direct variation. So 4 divided by 1, that's 4. 8 divided by 2 is 4. 12 divided by 3, and so on. They are all equal to 4. So that means that this is a table that represents a direct variation. 4 is the constant of variation. The function that you would write is y equals 4x. And again, we say y varies directly with x. Now, I'd like you to try this. Which of these is a direct variation? And for the direct variation, I want you to find the constant of variation and write the function. Please stop the video, copy these into your journal, write your results, and then restart the video when you're done. So if we look at the first table, there is no value of x equals 0 listed in the table. So in this case, we need to look at the ratios, or the ratios of y to x, or y divided by x. So here, y divided by x, negative 2 divided by 1 is negative 2. Here, 6 divided by 3 equals 2. And then we have 2.8 and so on. So we don't even have to look any farther than this to know that this first one is not a direct variation. In the second table, we first look to see that when x is 0, y is 0, so that could be a direct variation. And then we look at y divided by x. And each time we get 6, so that we know that this is a direct variation. The function that we would write for this is y equals 6x, and the constant of variation is 6. Next, we're going to see how we can tell from an equation whether a function represents a direct variation. And we're going to look at these 5. Now, we can look immediately at the first two and tell. So this one is written as y equals some constant k times x. So it definitely is a direct variation. In this one, if we multiply each side of the equation by x, we would get y equals 8x. And again, this is a direct variation. So the question is, what about these other 3? What we're going to do for each of these is we're going to solve the equations for y, and we're going to see if we can make it look like y equals kx. And if we can, then it's a direct variation. So this first one, we will subtract 3x from each side, and we'll get 7y equals negative 3x. And then we'll divide each side by 7, and we get y equals negative 3/7 x. So this is a direct variation. And the constant of variation is negative 3/7. Now let's take a look at this. 13x minus 17y equals 10. All right, so we will subtract 13x from each side, and we'll get negative 17y equals negative 13x plus 10. Divide each side by negative 17, and we will get y equals 13/17 minus 10/17. This is obviously not a direct variation. Let's take a look at the third equation. Now, the third equation, y equals 6x plus 11, is not a direct variation because it's not in the correct form. So we would need to see y equals kx, but then we have this other thing here, so this is not a direct variation. Now, I'd like you to try these 3 problems and figure out which of these is a direct variation. Stop the video while you do that, do all the work in your journal, and then restart the video when you're ready to look at your answers. All right, we can check these very quickly. If we try to solve for y by subtracting 10 from each side and then dividing by 4, we get this equation here. And this equation indicates that this is not a direct variation because it's not in kx equals y form. For the second one, we divide each side by 3, and we get negative 17/3 x equals y. So that is a direct variation, and the constant of variation is negative 17/3. Take a look at this last one over here. 12a minus 6b equals 0. One thing that we could do is we could add 6b to each side, and then divide each side by 6. And we see that we have 2a equals b. So even though we're not using x and y's, we're using a's and b's, this is also a direct variation, and the constant of variation is 2.